हेलो फ्रेंड्स, टैक्स मास्टर में आज हम देखेंगे op-amp applications of op-amps. First of all, you search on your browser tab OPMS applications. So first of all, you need to click on first website. So this is not a topic related op-amps. You want to return correct application of op-amp. Now search op-amp application. Here some op-amp applications are come in tutorial point. So a circuit is said to be linear if there exists a linear relationship between its input and output. So simultaneously, a circuit is said to be non-linear if there exists a non-linear relationship between its input and output. Op-amp can be used in both linear and non-linear applications. The following are the basic application of op-amp: inverting amplifier, non-inverting amplifiers, voltage follower. This chapter discusses this basic application in details. Inverter amplifier. An inverting amplifier takes the input through its inverting terminal through a resistor and produces its amplified version as the output. So an inverting amplifier takes input through an inverting terminal through a resistor R1 and produce its amplified version as the output. This amplifier not only amplifies the input but also inverts is changing its sign. The circuit diagram of an inverting amplifier is shown in the following figure. Note that for an op-amp, the voltage at the inverting input terminal is equal to the voltage at its non-inverting input terminal. Physically, there is no short between these two terminals, but virtually they are in short with each other. In the circuit shown above, the non-inverting input terminal is connected to the ground. That means the 0 volts is applied at the non-inverting terminal of the op-amp. According to the virtual short concept, the voltage at the inverting input terminal of an op-amp will be 0 volt. The nodal equation at its terminal node is showing below. 0 minus Vi upon R1 plus 0 minus V0 upon Rf equals to 0. Vi and R1 equals to Vo Rf. Vo equals to minus Rf upon R1 Vt. Vo upon Vi equals minus Rf upon R1. The ratio of the output voltage and the input voltage is the voltage gain or voltage of the amplifier. Therefore, the gain of inverting amplifier is equal to minus Rf upon Ri. Note that the gain of the inverting amplifier is having a negative sign. It indicates that there exists a 180 phase difference between the input and the output. Now we discuss non-inverting amplifier. A non-inverting amplifier takes the input through its non-inverting terminal and the produce its amplified version as the output. As the same name suggests, this amplifier just amplifies the input without inverting or changing the sign of the output. The circuit diagram of a non-inverting amplifier is shown below. First of all, in inverting amplifier R1 or F is negative ground and V1 is applied to positive. In above circuit, the invert V1 is directly applied to non-inverting input terminal of a PAM. So the voltage at the non-inverting amplifier of a PAM will be V1. By using voltage division principle, we can calculate the voltage at the inverting input terminal of the PAM as shown below. V1 equals to VO upon R1 plus RF. According to the virtual short concept, the voltage at the inverting input terminal of an op-amp is same as that of the voltage at its non-inverting input terminal. So V1 equals to VI, VO equals to R1, VO equals to R1 plus RF upon R1, VO upon V1 equals to 1 plus R1. So here is the basic concept. So here the voltage non-inverting amplifier is equal to 1 upon RF plus R1. The one that gain of non-inverting amplifier is having positive sign. It indicates that there is no phase difference between the input and output. Voltage follower. A voltage follower is an electronic circuit which produces an output that follows the input voltage. It is a special case of non-inverting amplifier. If you consider the value of feedback resistor RF as 0 ohms or the value of resistor 1 has infinity ohms, then a non-inverting amplifier becomes a voltage follower. The circuit diagram of a voltage follower is shown below. In the above circuit, the input voltage Vi is directly applied to the non-inverting terminal of op-amp. The voltage of the non-inverting input terminal of op-amp is equal to V1. Here, the output is directly connected to inverting input terminal of op-amp. Hence, the voltage at the inverting input terminal of an op-amp is equal to VO. According to virtual short concept, the voltage at the inverting input terminal of the op-amp is same as that of a voltage of its non-inverting terminal. V upon equals to Vi. So the input voltage is follower is equal to its input voltage. So Vi, thus the gain of a voltage VO input voltage of voltage same as. So we go on through next page. They come under the linear operation of a pen. So we back from this site and open new website. A linear amplifier like an op-amp has many different applications. It has a high open loop gain, high input impedance and low output impedance. It has high common mode rejection ratio. Due to this favorable characteristic, it is used for different applications. In this article, we discuss some of these points. The inverting circuit amplified with an op-amp, a non-constant distortion, comparatively low, provided a better transitory response. When op-amp is applied in an closed loop, there is a linear Relationship between input and output. The inverting amplifier can be applied for unity gain if Rf equal to R1, where Rf is the feedback resistor and R1 is input. Op-amp application. The input signal when applied to the non-inverting input is applied back to the input via the feedback circuit created by Rf and Ri, where Rf is the feedback resistor and R1 is input resistance. Voltage gain without any kind of phase inversion. In transistor equivalent, there are minimum 2 transistor stages needed to do this. High input impedance compared to inverting input. Easily adaptable voltage gain. The total remoteness of the signal supply from the output. Op-amp is used for direct coupling procedure, and so DC voltage level at the emitter terminal increase from phase to phase. This rapidly increasing DC volt level is likely to shift the operating point of upcoming stages. Thus, to move down the increasing voltage swing, the phase shifting is applied. The phase shifter performed by adding a DC voltage level to the output of all stage to pass output at ground level. So op-amp is a scale charger. Op-amp function as a scale charger through a small signal with constant gain is both inverting and non-inverting amplifier. Non-inverting terminal is ground, whereas R1 link the input signal V1 to inverting input. A feedback resistor is then connected from output to inverting. The closed loop gain of inverting amplifier work based on the ratio of two external resistor and RF, and op-amp act as a negative scalar when it multiplies the input by a negative constant factor, while in need for an output that is equal to input for getting multiplied. Scalar circuit.